Hi, my name is Harry Hu. This is Lab 2 Lines of Charge for Physics 2212 or Physics 2. So just some introductions. We're going to produce a computational model of two charge tapes exerting an electric force on each other and use this model to estimate the amount of charge on each tape necessary to float one above the other. So I need to distribute the charge evenly across the length of the tape in the computational model and not concentrate the charge at a single point. We're going to be using charge tapes to compare the point charge model to the charge model lines. So some fundamental ideas, we're going to need to use superposition, we're going to need to use the tape to model electric fields, and we're going to use, like in Lab 1, Newton's second law and Coulomb's law in order to calculate it. Just some assumptions, air resistance is negligible, gravity, force of gravity 2.17 times 10 to the power negative 3 newtons, same for force of the electric field of each tape. So the piece of tape charge is 2.88 times 10 to the power negative 8 coulombs. Each tape piece has the same charge, and the charge on each tape is distributed equally. And all these are assumptions that we make for the lab before the actual experiment. So in the experiment, so the condition is that the system is tape B and the surroundings is everything else. We're going to have two pieces of neutral tape that are equal in length, and then we're going to have a third piece of neutral tape that is actually taped partly on the desk with a different length. So the details of the lab will be tape B is going to be stuck to the tape on the desk and ripped off quickly. The tape is then going to be hung near another object to determine its charge, and then we're going to be able to determine the charge based on the distance. So here are our calculations. Tape mass, we got the 0.00022 kilograms, tape length 0.22 meters, tape distance 0.27 meters, force of gravity 0.00218 newtons, tape charge 1.34 times 10 negative 8 coulombs. So here's my Glowscript code. I'm just going to give you a minute to just go over the code and just read through what I typed. So here's my Glowscript model. This is what I got after I ran the Glowscript code. You can see the magnitudes of the electric force and gravitational force change after the experiment, or is a result of the experiment. Also going to give you some time just to look over the model. So here's our discussion. First, we're going to talk about the errors that may have occurred. The charge may not have been distributed equally. We might have had some human mistakes that I personally made, and our results will not be 100% effective. Here are the questions. For the first questions, I'm just going to answer it. So my value for this lab was about 2 times the value of the lab 1, and I believe the estimates are different because we're doing different ways to solve it. The first one we did a point charge, we took 1 point, and then this one we're going to be using an integral to kind of cover the whole charge of the object. And I think the value is most likely to be closer to the real value is the value we got in this lab or the value we got in lab 2, because the integral that we're going to use to cover the whole object is more accurate than taking the charge at a single point, assuming that 1 point is even part of the whole charge. So thank you for listening, and just have a great rest of your day.